Complete solution of mathematics for class 10 under the syllabus of Board of Secondary Education Manipur. Solved, recorded and edited by I. Salam Megasundar Singh, lecturer, Sursar Higher Secondary School, Imphal. Frustum of a right circular cone. What is frustum? If a right circular cone is cut off by a plane parallel to the base, right circular cone amabu base ka parallel oiba plane amana makak ani thona kaklabadi makha thangba makak asibu aikoina kari kawi portion asibu frustum kawi. The portion of the cone between the plane and the base of the cone is called a frustum of the cone. Volume of the frustum of cone sigi cone asigi frustum asigi volume di 1 by 3 pi is r1 square plus r1 r2 plus r2 square. From asida cone adugi base asini sigi radius asibun r1 korasi matak thangba base asibun mahaki radius adubun r2 korasi. Sigini sibaki awangba adubun aikoina height aduga sigi awangba sigi slant height kawi l ni denote gani. Hojik line si chinglabadi sigi makak asi R1 na R2 dagi chaurabani na R1 minus 2 R2 na khangnagani sina base sina lateral surface sina curved surface area base base 1 gi sina base 1 gi area sina base 2 gi area. Curved surface area of the frustum di pi sigi curved surface area di pi L R1 plus R2. Total surface area of the frustum di pi times of L R times of R1 plus R2 plus R1 square plus R2 square. Asi mathak amasu makha sigi jaga ani sigi area asini. Curved surface area di mathak laigare sigi base 1 sigi area sigi circular section sigi area adubani aikoina sida piribasi pi times of R1 pirisi. Then mathaki circular section asigi area asibuni aikoina pi times of R2 na piribasi. Then pi na sida purisulabadi mathaki curved surface area of the frustum je phangani. Slant height habadi sigi L sigi value ni si awang basi so ice oirabadi ki right triangle ni Pythagoras theorem palabadi L square equal to I square plus R1 minus R2 whole square. Mensuration volume and surface area of a frustum. Volume amasung surface area puthokpani frustum gi. Exercise 12.6. Question number 1. If the radii of the circular ends of frustum of height 6 cm are 20 cm and 12 cm respectively, find the volume and the curved surface area of the frustum. Take pi equal to 3.14. R1 asina mafam asida base asigi area asini R2 asina mathak thangba sigi area base 2 gi asigi radius ni. Then height asina asigi 6 cm 6 ni. Then L square d sigi L sigi square d sigi R1 minus R2. This is Pythagoras theorem sida palani. We have this. Sidiki kun slant height puthokani. Then ice ki value pisilo R1 na 20 pisilo R2 na 12 pisilo. Then sum up toro the L ki value to 10 cm phangani. Volume of the frustum di magi formula di 1 by 3 pi ice times of R1 square plus R1 into R2 plus R2 square. Giving their respective values pi the 3.14 period ice the 6 period R1 in a 20 R1 20 into 12 plus 12 square. Values in a sum up toro we have 4932.52 centimeter cube asigi volume ase phangani. Next surface curved surface area of the frustum ni. Curved surface area of the frustum ni pi L times of R1 plus R2 bako respective value pichil asi simplify toro si 1004.8 centimeter square point. Question number 2. A bucket is in the form of a frustum of a cone if the height of the bucket is 16 centimeter and the radii of the upper and the lower ends are. are 18 centimeter and 6 centimeter respectively. Find the height of the cone of which the bucket is a part. Find the height of the cone of which the bucket is a part. As in this picture, bucket amasi cone ama semle, masina aikoina R1 oina khangnarani, sina R2 oina khangnarani. Then we have to find height of this cone. A O B habisi cone amani. R1 asina mafam asida 18 centimeter, R2 asina 6 lore, height to 16 centimeter ne. 16 centimeter se kanana height of the bucket sige awang mani bucket sige awang badi 16 centimeter ne. Bucket asina part ama oriba bucket asina part of a pole ne. Right circular pole ne. Adugumba pole dugi awang ba puthu u haiben. Pole dugi awang ba that is L dagina O pogi awang ba si puthu haiben. Let OAB be the cone in which the bucket is a part. Bucket A B C D have a C bucket is a part amani, and let OL be the height of the cone OAB. Aduguma cone adugi awang badu OL na khangnarani. Since triangle OMC since triangle OMC usigi OMC hariba triangle siga. Then similar to triangle OLA hariba triangle siga similar ore. Therefore corresponding sides are proportional. That is CM divided by AL equal to OM divided by OL. Hariba terms in respective value period CM haibasidi R2 की value ni R2 की value di R2 की value di 6 ni AL haibasidi kaya ga manai AL haibasidi R1 maha की value di 18 ni. Then OM haibasidi OL dagi LM that is 16 khaido ki bok manai OL. Then cross multiply and solve OL. We have OL is 24. OL ki asang was 24 ni. This is the height of the pole of which the bucket is part. Thus the height of the pole of which the bucket is a part is 24 centimeter. Bucket asina part ama oiba pole adugi awang madudi 24 centimeter oigan. Hoziki question dugi makha chatharakpani anisuba Roman number 2 gi damakta the capacity of the bucket adugi volume puthu haibani. Here this. The capacity of the bucket is 1 by 3 pi s times of R1 square plus R1 R2 plus R2 square. Hariba terms in a respective value in the picture. Let's see ice ki value this 16 ne ice ki value this 16 ne R1 value 18 ne R1 18 R2 6 R2 6 square. Value singa sufficiently evaluate tore we have 7844.57 centimeter cube. Roman number 3 question number 2 gimakha satharakpani Roman number 3 the slant height of the bucket to put high. Roman number 4 the surface area of the bucket. The slant height of the bucket L equal to root over I square plus R1 minus R2 whole square. And respective value visually I is the 16 piro R1 18 R2 6 and simplified or we have 20 centimeter. Bucket adugi slant height bucket adugi slant height avadi CC poina kaya pange 20 centimeter or the surface area of the bucket bucket chigi surface area. The surface area of the bucket kiri mathak thangma portion asi mahaki hollow oigani then makha gi sorani slant height sigi slant height sigi slant height sigi mahaki area plus sigi makhagi bottom sigi area sigi surface sigi bottom area mathaki area sikoi counter oi then makoi gi value bisilani we have this simplify toro 1621.71 centimeter square phone bucket we begin mathaki se count of previous plus r1 square half previous. Question number 3. A bucket is in the form of a frustum of height 21 centimeter. The diameter of the top and the bottom are 70 centimeter and 56 centimeter respectively. Find the capacity of the bucket. Bucket ama habisi frustum ni 21 centimeter gi mawongda diameter top amasung bottom adugi diameter do 70 centimeter and 56 centimeter ni. Find the capacity of the bucket. Bucket ki capacity putu haibani. R1 to diameter piram labadi radius putum labadi damak diameter 2 yelaga R1 R2 hangani then R1 amapum R2 regi chawe is to 21. The capacity of the bucket is B formula se palani then respectively location simplify toro we get 65758 centimeter cube hang. Then masi liters to how many liters capacity liters to kungi higher gadi 1000 yengani karigi damaka 1000 yelibano 1 liters habisi 1000 centimeter cube pudingi 1 liter so 1000 pudingi 1 liter habisi 1000 centimeter cube kumane how many 1000s are there haragadi 1000 divide torani 65.76 liters sali bucket adu. Question number 4. The circumference of one plane face of a frustum is 44 centimeter and that of the other is 66 centimeter. If the height of the frustum is 12.6 centimeter, find the volume. Circumference of one plane face of a frustum is 44 centimeter and other is 66 centimeter. Then Shidamana hangibadi frustum si karamba frustum no haragadi si frustum ahan aman silerani then amana saholasi amana piallabadi then circumference to the let R1 and R2 be the radii of the two plane faces such that R1 is greater than R2. Then twice pi R1 is 66 from which R1 ki value equina putho ani 10.5 centimeter. Again twice pi R2 is 44 sidigi R2 ki value putho ani 7 centimeter. Volume of the frustum this sigi formula se palani respective value simplify simplify torani equina kaya phange 3072.3 centimeter cube. Volume of the frustum the siorani. Question number 5. A glass tumbler is in the form of a frustum of height 12 centimeter. The diameter of the upper and the lower ends being 7 centimeter and 4.2 centimeter respectively. Find the capacity of the tumbler. Use pi equal to 3.14. Here R1 is 7 by 2 centimeter, that is 3.5 centimeter. R2 is also 4.2 by 2 centimeter, that is 2.1 centimeter. Ice is height 12 centimeter. Capacity of the tumbler, use this formula, give their respective values and solve. We have 301.57 centimeter cube. Question number 6. The perimeter of circular ends of a solid frustum are ITI centimeter and 66 centimeter and its slant height is 21 centimeter. Find the total surface area of the frustum. Find the total surface area of the frustum. Let R1 and R2 be the radii of the circular ends of the solid frustum such that R1 is greater than R2. Then asoba perimeter so 1 is twice by R1 is equal to asoba perimeter ka मान halani which gives R1 is 14 centimeter. Again amuksu twice by R2 is equal to apipa perimeter si ka maan halani R2 ki value solve torani to 10.5 centimeter. The total surface area is this. Use this formula, give their respective values and solve. We have 2579.5 centimeters square. Question number 7. A container is in the form of a frustum of height 12 centimeter with radii of its upper and lower ends is 17 centimeter and 8 centimeter respectively. Find the course of milk the container can hold at the rate of rupees 20 per liter. Also, find the curved surface area of the container. Here R is 17 centimeter, R2 is 8 centimeter, I is 12 centimeter. Find the course of milk the container can hold at the rate of rupees 20 per liter. Then slant height is used as formula giving their respective values and solve. We have L equal to 15 centimeter. Capacity of the container is volume of the frustum. That is giving their respective values. Simplify, we get 6141.84 centimeter cube. The capacity of milk in the container is how many liters are there. We have to divide this volume by 1000 liters. Is 1 liters equal to 10,000. 1 liter equal to 1000 centimeter cube. Then 6.14 liters. Cost salt milk is rupees 6.14 into 20 is 20 rupees 20 per liter. And we have 122.8. Also find the curved surface area of the container. The curved surface area of the container is pi L times of R1 plus R2. Give their respective values and simplify. We get 1177.5 centimeter square. Question number 8. A cone of height 8 centimeter is divided into two parts by a plane through the midpoint of the axis of the cone and parallel to the base. Find the ratio of the volume of the conicant part to that of the frustum. Karigumba cone 8 centimeter wangba cone amabu mayaida base na parallel oiba plane amana khaidokle. Adugumba cone adugi part aduda frustum adugi volume yenbagi ratio podo. Let R1 and R2 be the radii of the frustum and the cone such that R1 is greater than R2. Here R1 should be this. This should be R1. This should be R2. This is ice. This is midpoint. Then the height of the cone. Height of the cone OCM. Height of the cone is ice by 2 because this point is the midpoint of OL. We have triangle OMC. Similar to triangle OLA. Therefore, OM divided by OL equal to CM divided by AL. Giving their respective values, we have this, from which R1 equal to twice of R2, which is equation 1. Now, volume of the cone OCD, volume of the cone OCD, volume of the cone OCD, volume of this cone, volume of this cone divided by volume of the frustum, volume of the frustum, that is volume of this frustum, which is what volume of the cone is 1 by 3 pi r square ice, that is ice by 2. For volume of the frustum, 1 by 3 pi whose height is ice by 2, r1 square plus twice r1 r2 plus r2 square. Giving their respective values and cancelling and giving their respective values, we have 1 by 7. Question number 9. A cone is divided by plane parallel to its base into a smaller cone of volume V1 and a frustum of volume V2. If V1 is to V2 is 8 is to 19, find the ratio of the radius of the smaller cone to that of the given cone. Find the ratio of the radius of the smaller cone to that of the given cone. Let R1 and R2 be the radii of the smaller cone and the given cone respectively. Smaller cone and the given cone. Smaller cone and given cone. Let S1 and S2 be the radii of the given cone and the smaller cone respectively. We have OMC. OMC is similar to OLA. Therefore, corresponding sides are proportional. OM divided by OL equal to MC or CM divided by AL or LA. Giving their respective values, we have IS1 divided by IS2 equal to R1 divided by R2, which is question 1. Now V1 divided by V2 is equal to I by 19. V2 implies V2 by V1 equal to 19 by I. Adding 1 on both sides, we have this sum up, then which is what V1 plus V2 is volume of the given cone divided by volume of the smaller cone, which is 27 by I. That is, volume of the given cone is 1 by 3 pi r square pi r1 square into is1, and the volume of the smaller cone is 1 by 3 pi r2 square is2 equal to 27 by I. Cancelling respective terms, we have this is1 is2 is found to be r1 by r2, then which is cube, then which is 3 by 2 whole square. Cancelling r1 by r2 is equal to 3 by 2. R1 is to R2 is 3 is to 2. Question number 10. A circular cone has a base of radius 10 centimeter and height 25 centimeter. The area of the cross section of the cone by a plane parallel to its base to 154 centimeter square. Find the distance of the plane from the base of the cone. Let R be the radius of the cross-section plane. Then area of the cross-section plane is 154. Area of the cross-section plane is this is 154 centimeters square, which is whose value is 27 pi r square. There is this 154, from which we have r equal to 7. Let a centimeter be the distance of the plane from the base of the cone. Sigi kondagi mahaki arapasi aisne hane logsilasi. Then height of the cone or OCD hasigi height asidi out of 25 tagi ice logthokrabadi siga height orani. Since CM divided by AL equal to OM divided by OL, sigi triangle and is similar oibanina CM asida AL na yenbaga OM asida OL na yenbaga mane. Giving their respective values, we have this and cross multiply and solve ice. We have 7.5 centimeter. Find the distance of the plane from the base of the cone, which is 7.5 centimeter. The distance of the plane from the base of the cone is 7.5 centimeter. Question number 11. A circular cone is cut by a plane parallel to the base and the conical portion is removed. If the curved surface area of the frustum is 15 by 16 of the curved surface area of the whole cone, prove that the height of the frustum is 3 by 4 of the height of the whole cone. A circular cone is cut by a plane parallel to the base and the conical portion is removed. If the curved surface area of the frustum is 15 by 16 of the curved surface area of the whole cone, prove that the height of the frustum is 3 by 4 of the height of the whole cone. Let R1 and R2 be the radii of the bases of the cone such that R1 is greater than R2, as in this picture. Let is1 and is2 and is be the heights of the poles OAB, OAB, and OCD, and the frustum CABD, and L1, L2, L be the respective slant height. Sig slant height ne L1 lower C, sig upon begin L, sig L2 lower C, sig L lower C, sig L lower C. We have OMC triangle OMC similar to triangle OLA. Corresponding sides are proportional, giving their respective values. We have all now curved surface area of the frustum sigi curved surface area divided by curved surface area of the pole sigi curved surface area is given as 15 by 16. Giving their respective values, we have this, and so from which we have to solve L by L1. L by L1 is equal to L is equal to this L is equal to L1 divided by minus L2. We have this. divide, we have this, and sheet L2 by X1, L2 by L1 to the X2 by X1 ka man hore, R1 R2 by R1 to the X2 by X1 ka man hore, using a minus b whole into a plus b, the a square minus b square this, and from which we have this. Then solve. X2 by X1 is found to be 1 by 4. Height anigi distance to ratio do matu nakan animakta aikoina sigidi X2 or sigi X1 plus X ne dividing, we have this. X is equal to 3 by 4 of X1. Hence the height of the frustum is 3 by 4 of the height of the whole pole. Whole pole adugi awangba dudi X1 sigi awangba si koina awang the sigi awangba si X1 haina low given. The height of the frustum, the sigi height to the koina X low given. Question number 12. From a cone of height 24 centimeter, a frustum is cut off by a plane parallel to the base of the cone. If the volume of the frustum is 19 by 27 of the volume of the cone, find the height of the frustum. From a cone of height 24 centimeter, a frustum is cut off by a plane parallel to the base of the cone. If the volume of the frustum is 19 by 27 of the volume of the cone, find the height of the frustum. Let R1 and R2 be the radii of the cone such that R1 is greater than R2. And let X1 and X2 be the heights of the cone. Heights of the cone. Height of the cone. X1 is the height of the cone. Karamba X1 is the height of the cone. Asoba sige X2 is the cone macha sige. We have triangle OMC similar to triangle OLA. Triangle OMC is OLA similar. Therefore, OM divided by OL equal to CM divided by L. Giving their respective values, we have this. This is question 1. Now, volume of the frustum divided by volume of the pole OAB is equal to 19 by 27. Volume of the frustum is volume of this frustum is volume of the cone minus volume of the smaller cone. Then volume of the cone divided by volume of the cone OAB equal to 19 by 27. Masari everybody, we have 1 divided by this. Solve, we have volume of the cone OCD divided by volume of the cone OAB divided C1 Jigi nakanda 19 by thanga the I by 27 phangani. Now C ki value the 1 by 3 pi R square C OCD ki volume the R2 ni radius to maha ke height to na ice to ni. Aduga volume of the pole achauba sigi di maha ki di aikoina kaya low kare height to ice 1 low kare maha height to ice 1 low kare. Cancelling. Cancel, we have R2 by R1 whole square, then whose value is X1, X2 length and thamani. This is Shidmathamaka honor I by 27. We have X2 by X1 magi value pishilani, then cube larani CD2 by 3 whole cube ni cube root log we have this. X2 is what 2 by 3 times of X1, but X1 is given as 24, the equal 16 phangani. Thus, the height of the frustum is the X1 minus X2. That is height of the whole cone. Again, height of the smaller cone of height of we have 8 centimeter. 8 centimeter or question number 13. A cone is cut into 3 parts by planes through the points of 3 sections of its altitude and parallel to the base. Prove that the volumes of the parts are in the ratios 1:7:19. Kariguma cone amabu part ahum thona khaidoi. Part ahum thona mahaki cone amabu ice cone amabu parallel base na parallel oiba altitude pu saruk ahum thona 3 sector ba adugumba plane ahum na khaidoi. Let R1, R2, R3 be the radii of the cone such that R1 is greater than R2, R2 is greater than R3, and let S be the height of the cone OAB. Upon basigi pole sigi awang basi aikoina masi ice log sile. And then OP is equal to OP PQ QR makoi ahum si 1 by 3 ice because hariba plane singa sina altitude sibu 3 sector given. We have triangle OPE. Triangle OPE is similar to OQ triangle OPE hariba triangle sigi triangle siga triangle OQ siga OQC siga similar oi. Corresponding sides are proportional giving their respective values. Cancelling, we have R2 is equal to 2 times of R3, which is equation 1. Again, triangle OQC, triangle OQC siga triangle siga. So triangle ORA siga amok similar oi. Therefore, OCQ divided by AR equal to OQ divided by OR. Giving their respective values, cancelling, we have R1 is 3 by 2 times of R1, but R2 is equal to twice R3. Cancelling 2, we get 3 R3, which is equation 2. Volume of the cone OEF is 1 by 3 pi R3 square into S by 3. Then which is equal to this. Cancelling, we have multiplied this. Then volume of the frustum ECD is equal to 1 by 3 pi, whose height is h by 3. And using this formula, we have this. Frustum formula panjolani simplified thoroughly. We have this. Then volume of the frustum CABD is 1 by 3 pi, whose height is also h by 3. This. Giving their respective values, we have this. Simplify, we have this. The required ratio of the volumes of the party, this is to this is to this, which is 1 is to 7. Cancelling, we have 1 is to 7 is to 19. Hence proof. Question number 14. A bucket is in the form of a frustum with a capacity of 455 I4 cubic centimeter. If the radii of the top and bottom of the bucket are 28 centimeter and 21 centimeter respectively, find its height and surface area. R1 is 28 centimeter, R2 is 21 centimeter. Let S be the height of the bucket. The volume of the bucket is this, but whose formula is 1 by 3 pi, whose height this, and we get this. And giving pi equal to 22 by 7, S equal to R1 the 20 and R2 the 21. This law simplify to S equal to 24 centimeter. Find the height and surface area. The height of the bucket is 24 centimeter. Also, again, slant height is use this formula and find out slant height 25 centimeter. We have to find out surface area. Continued. Here R1 is this, R2 is this. They show the surface area of the bucket. Use this formula giving their respective values and solve. We have 5236 centimeter square. Thanks for watching.